Yeah, Indian students can change the world because, it's if they have the habit to approach things systematically, then imagine, how many students here is really big population, and I know Indian students are really good at engineering things, and the STEM things. And if they have systematic and critical thinking skills and they approach real world issues in through that approach, then I believe there will they they can solve many issues the world is experiencing right now, and the world will be a better place.
Welcome to Will Talks podcast. Today I am with Hugh Kim from Korea. And Hugh Kim has a lot of experience in training students around the world on robotics and computational thinking. He's worked with teachers and students across several countries. And I am absolutely delighted to have him at our studios today because we're going to spend the next hour talking about robotics education in India, the scope of robotics, how you, as a principal of a school, can begin to look at starting a robotics program inside your school, and what are some of the considerations that you need to keep in mind as you do it. So, welcome, Hugh Kim, to the Will Talks podcast. How are you feeling today? And is this your first time in India? Share some of your experiences so far.
First of all, I really appreciate this chance, and also thank you for having me here. Yeah, this is my first time to India, and now I'm here for some reason. But I really liked it, and I really love to have a conversation on the topics you just mentioned, and I hope my insights or my answers can help someone in India who thinking of starting robotic programs in schools and or home. Yeah.
Oh, that's really amazing. And what other countries have you traveled before coming to India?
Before coming to India, I went to twice a year. I usually go to the United States to attend an education exhibition, and also to train teachers, STEM teachers right there, and also all the Asian countries. And before coming to India, I went to the UK, Poland, Luxembourg, and also some countries in Africa, Ivory Coast country, Cote d'Ivoire, and also Nepal. None of Kenya as well.
Wow. And in these countries, have you visited schools and classrooms and spoken to teachers or students there?
Yes, I met many teachers in each country, and I met students right there. And also sometimes I meet like partners in educational sectors. And these meetings have given me some chances to think about the different circumstances in each country and also different insight.
So, what notable differences have you seen between classrooms and teachers across different countries that you have visited from your personal experience?
From my personal experience, each country has its own color in education. Like, for example, I can, it is not 100%, but in India, now I'm realizing that STEM majors are really important in this country. And all the education sectors are heavy focus on these majors as an evidence, like IIT, one of the most finest universities in the world. Many students have goals to attend the university, and that university is, of course, has its focus on engineering majors, right?
Yes.
That is the trend India has. And when it comes to the United States, I cannot pick on behalf of them, but
Of
however,
course.
however, they are really passionate about engineering majors, but also they have a tremendous and also heavy focus on social science majors as well.
Okay.
But the thing is, even though like social science majors have like things on their own, they need to learn like engineering stuff and STEAM stuff to solve their own issues as well.
Mhm. How would you expand STEAM? STEAM. How would you expand that?
Actually, many people are familiar with the term STEM. STEM is yes, as in science, T as in technology, E engineering, and mathematics. But STEAM, we add one more letter, A, arts. Arts.
Oh.
That's why it that is how it becomes STEAM. The the difference is yeah, literally, it has one more letter, which means one more discipline. So it is more cross curricular things. It emphasizes creativity by using the knowledge we learn from STEM majors, and ultimately students need to express things on their own through the knowledge. That's team.
That is beautiful because from what you're saying is the A allows the STEM to become something of value to the world.
Students actually they are really good at, especially the earlier they are they want to express their own things with their out of their creativity and through STEAM education, especially in 2023 we are living with machines, right? In this digital era, through STEAM education, students can learn how to express things and how to solve real world things, real world issues through STEAM education.
So when I was in school, about 20, maybe about 30 years ago,
Oh, really?
when I was in school, I remember there was a distinct difference between students who liked science and math and students who did not want science and math. So after school, in high school, we had to select whether you want to do math, science, and biology, or whether you wanted to do the arts, the English, and the other. What we are noticing now is that a lot of people who did not have any maths or science background, when they go ahead in life, they find it difficult to take lots of decisions which include mathematical operations. And the maths people, the students who were very good in only STEM, they found it difficult for interpersonal connection, collaboration, group work, and things like that.
Yeah.
Any thoughts about this and the need for everyone learning about,
Yeah.
STEAM?
I think it happened in the past because universities and college level schools have actually they categorize different majors. Actually, this right now there are reasons why they do this, but today like those two passes like social science, humanity, and engineering thing, they are getting closer to each other because only one side knowledge cannot solve real world issues. If someone is really good at engineering and technology things, and if he wants to solve some issues people are facing today, he needs to understand their he needs to be in their shoes, right? It's social science things. Yeah, he needs to understand the like cultural difficulties behind the issues, and also he needs to understand the social circumstances they are experiencing. So not only one side knowledge cannot solve like issues. That's why now universities are actually non-engineering major students. They are learning engineering stuff in freshman and sophomore, of course. But as they move on to junior and senior, they specialize in their majors, but they need to learn basic principles of the other knowledge. And it's the same to the engineering students. They need to learn humanity and social sciences so that they can understand why they learn this stuff.
This is absolutely brilliant. And one thing that comes to my mind that you said was we are living among machines. What do you mean? Am I living among machines?
Okay. As we look around right now around the desk, now I have this mic. You have a mic, and I have a laptop here, and now the cameras are rolling. Those are our machines, right? And right now I can see more than 10 monitors
Mhm.
and air conditioners. We control the air conditioner with the remote control. Right?
Yeah.
It's machines. They are machines, right? Actually, we cannot help living without machines nowadays. It's
Mm.
true because we became too much used to it. Used to living with these machines. Without machines, our lives would look much more different from current lives we have.
And so when we're living among machines, so uh, do you mean to say that we as human beings or students, children, as they grow up, the human machine integration skills is a new skill that we have to teach children because earlier they did not live among machines, and so we didn't have to teach them that. So do you think it's a new skill, the human machine integration skill?
Yeah, that integration is really essential, of course, but it is not safe to like judge which age are good to be exposed because each child has a different digital literacy level. Because some parents don't want their children to use smartphones when they are in kindergarten level. Then the students, I mean the children, don't know how to use it, and they are not familiar with the smartphone stuff, which means they have less chances to be exposed to like yeah, digital things compared to other students who already use smartphones. So actually, digital literacy levels are really different of students by students. So, however, it is true that the integration should be made. The earlier they are exposed to this integration, the better chances they can have to understand and learn much faster than others who don't have any access to these
That's brilliant.
machines. Yeah.
So I want to now ask you this question because you set the context of human beings living with machines. Is Tesla just a car, or is Tesla like any other car that we know, or is it more than that?
Oh, it's a good question to and think about. But Tesla is definitely automotive company known for its electronic cars, electronic vehicles. Although Tesla's cars are different from conventional vehicles that use combustion engines, yeah, fueled by gasoline and diesel. Tesla manufactures cars because those cars have four wheels and carry people, right? And the purpose is same, but the difference is Tesla is the only company, and this is my personal opinion, is the only company that can solve traffic issues the world is experiencing because it is not just a conventional car, but it comes with a robot. Yeah,
Oh,
robot. Yeah, that's why I believe the company has the potential to solve the traffic issues in the world.
so Tesla cars is basically like a computer and a robot with wheels that also happen to move people from one place to the other.
Yeah, right. It has the same purpose. If when it comes to saying like carriage, then it has the same purpose. But as many people already know, Tesla is known for its self-driving functions, right? And that special function is possible because it is technology, AI things, and the data collection, and that's why I believe actually this is an example. For example, conventional cars, drivers should put their acceleration to move forward, right?
Correct.
And there's a travel time when you decide to, let's move on. Then your brain has the signal and transmit the signal to your leg, right? But which means if there's a green light, then each driver needs the travel time, so which that that causes traffic jam as well. But Tesla driver drivers don't have to think about this
Wow.
because they they self drive. They self drive when the green light turns on. Then yeah, before you think about it, Tesla already make a decision to move forward, and they move at the same time, which means there are many waste of time waiting. The driver in front of you for
Okay.
for moving forward, but Tesla can solve this issue.
But this is brilliant. So, is there that shows that there's a big scope
Mm,
for robotics,
mhm,
especially in a country like India?
definitely.
And India is talking about the Make in India.
Mm,
And India was essentially a services economy
mhm,
where people wanted to get into jobs which were developing services
mhm,
and giving services to other countries,
Mm.
other nations. So Infosys and Wipro and some of the large HCL, some of the large software services. India was known for, its large human capital for software services. What we feel we are moving towards is a little push towards manufacturing,
mhm.
make in India. So, considering the make in India movement, what do you think is the scope for robotics in India? And will it help our children get better jobs?
The scope of robotics, actually, the scope is really vast
Mm.
and it's still expanding. When it when it comes to education, robotics are only limited to like educational tools. They can be, yeah, if that is under K-12 below university levels. But actually, the scope of robotics it encompasses like all the things in the fields like agriculture and healthcare, and also aerospace things.
Healthcare.
Yeah. What is everything or every industry that needs some machine? Then they can be. It's safe to say that industry is in the scope of robotics. Yeah, because robotics make it much smoother
Mm.
for each industry to uh, process their tasks.
Mm.
They do things instead of humans, like uh, for example, Mine industry, we use machines. In the past, we we did ourselves to using like only tools without machine. I like tools only. But nowadays, like electronic machines do things, do dangerous things instead of humans.
So it
And
saves human lives.
right. So also this industries, robotics encompasses this industry as well because it's already the industry already uses the technologies of robotics. Mhm. The scope is really vast. And
So what I'm getting is no matter what industry you're in,
Mhm.
there is a place for robotics.
Sure,
So
right.
students who learn robotics, fall in love with robotics, start thinking
Mhm.
about how they can use robotics, can find a place in any other industry that they would want to go to.
Every industry, but
Every.
except for except for like meditation, meditation things. Yeah, of course. Every industry needs robotics and technologies because we want to have safer solutions and safer tests. And if there are dangerous things that humans need to do, in the future, robots will be replace those roles. Those roles, and so that we can stay safe.
I was attending a TED talk once and I met this amazing gentleman
Mhm.
who saw manual scavengers. What it means is, the drains, the city drains,
Mhm.
there would be human beings going down in the drains to clean the drain.
Wow.
And many times they have died because of harmful poisonous gases
Right.
in the drain. This man, he made a robot that can go inside the drain and do all the cleaning of the drain. And that has been saving lives.
That's great, and that is one example of how robotics can be used to save human lives. Yeah.
So there it is now absolutely obvious to me that our students in our schools in India, our students in our classrooms need to understand robotics, need to play with robotics, need to learn to think in a way whereby they can solve problems using machines and using technology. I completely understand. So, for a principal who wants to think about starting robotics in their school, what are some of the things that she should know? How can we start teaching robotics in the school, and from what age? Any idea?
First, if the school wants to introduce robotics to their classrooms, then nowadays there are many options to have. First, the school needs a robotic tool, like robotics educational tool to teach students, and also if I were the principal, I would consider if the curriculum the tool provides is a right choice for my school. Definitely, that's one consideration I need to take, and when when I looking at the tool, I need to think about how easy it is for teachers and also students, because some tools are really complicated for those in low digital literacy level students. So it should be intuitive and it should be easy to use, and also it should be safe to use as well. Yeah.
So I just want to understand this a little more when you talk about safety, because when I think about robotics and I'm thinking about hot soldering irons in the classroom, and children are soldering wires and connecting wires. In many Indian classrooms, there is only one plug point. How many plug points do we have in a classroom, or the level of safety that is required? Is there anything you can show me? Do you have anything to show me in terms of what robotics is? Because when there is earlier, about 20 years ago, or I think 30 years ago, one of our ex-prime ministers, Rajiv Gandhi, brought in the internet and the computer revolution into the classrooms in India. So he said children should learn computers, and everyone was learning basic programming, and then Fox Pro and a little bit of Word Star. And I was, in ninth standard is the first time, eighth standard, first time is when I experienced a computer with Word Star, and we were using MS-DOS. Today, when we are teaching computing to children, it's not only screens. There is also a physical component. So are you saying that teaching of robotics can also slowly help with screen addiction, where children break away? Because so many parents are worried about screen addiction. Could teaching of robotics be one solution for breaking away from screen addiction? And if you have something to show me, it'll be nice.
Oh, yeah. Oh, fortunately, I have something here.
But you can take the screen addiction question first if you'd like. Yeah.
Yeah. First, with this tool, parents don't need to worry about screen addiction. No screen needed.
Okay.
So, and to answer the question between like the software things on the screen and also physical computational education, the difference is with physical tools, students can see the results of their work immediately after they unload lines of the code they just wrote. They can, for example, like these modules, like It's a modular type, yeah, but each device has its own internal memory and processor inside.
So there's no wires,
No wires,
no
magnets,
soldering.
only magnets here. So the students don't need to think about complicated wiring things when they use.
So no burning.
No burning, and also this one considered safety, or because like kindergarten students sometimes try to swallow things.
Oh, it's big.
Yeah, it's big. Yeah, we took that into our account when we made this, and so this one was born of the idea that every device around us can be made through a simple approach, and now each module has different function, its own function. Like for example, this one is called environment module.
Uh-huh.
It senses temperature, humidity, luminance, and noise level.
Wow.
And like this one,
Mhm.
as it looks like, it is LED module. It
Oh.
emits lights.
Uh-huh.
The reason why there are 13 different types of modules here, and the reason why we made this way is, for example, uh, students need to learn robotics to solve real world issues, right?
Yes.
And like, as you can see around us, there are different types of devices. And some devices are called smart home devices,
Yes.
through IoT technology. And like, if we go outside, there are people like doing things in the farms and also warehouses with this environment module. Like, if they make some creations, and the creations can senses temperature and like humidity to make those like grasses safe. Mhm.
This is brilliant, because you're saying what children
Mhm.
write on code
Mhm.
can then be transferred immediately
Right,
into this.
right.
And then it's a working model.
Working models.
So children start physically
That's the thing.
interacting.
Yeah, that's the thing. It's the hands-on experiences, hands-on activities. Students have too much focus on software things only. Then, like you said before, they are screen addicted. They need to look at the monitor all the time, because what they are making is only software. However, if they learn how to use software and the hardware, and like integrate those things together, and if their software knowledge turns into like reality things, like hardware, so that they can see the results of their codes they just wrote, and they can check how their codes affects these hardware tools. It's robotics. So actually, I had a chance to witness a group of students in Korea, and they made a smart farm.
A smart farm.
Yeah, like they made they used this environment module and also other modules to detect to grow their crops safe in a better condition. Because if 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 the farm needs some care, then this display or sound modules warns the farmer of, it's time to give them water, and time or they need moisture. And students build those creations only with these modules.
Which now I can understand a little better now in terms of why the arts is important in the STEM, because this is the STEM. And by teaching children how they can use software to manipulate and use hardware to solve a real world problem that they see And this is in some ways like an invention. We are teaching children to become inventive. We are teaching children to become inventors. We are able to teach children to look at a problem, identify a problem, and then they come back to their workshop, you know, and they put something together
Mm-hmm.
to try and create, in India we call it jugaad. We try and create a solution for that.
Mhm.
And it could be, it could be as simple um, as that. And I think that will give confidence to children.
Right. As they learn how to use these devices and how to program these devices, they are becoming confident because actually before before the exposure to this knowledge, usually kids think the devices around us are really complicated to build and it's almost impossible for me to build such a device. However, as they learn how to program each device and by learning different computer languages, and they can become much more confident because they realize these devices are made by humans. Mhm. And these are complicated, but I can solve or I can make it through. Like
Wow.
because that's that's what we emphasize through our curriculum: critical thinking, problem solving, logical thinking, and also sometimes people need teamwork.
Yeah.
Yeah, so collaboration skills. We want to foster those skills to prepare the students for like the 21st century labor markets. They actually these are really essential skills, and they need to learn those skills through robotics and programming nowadays because the you know the world is changing into the digital world, and this became a part of our life.
I have a story to share. I went to a friend's house once,
Mhm.
and he had a little. He had a little son, maybe about 5 or 6 years old, and I saw a lot of toys
Mhm.
in his house, and I asked him to give me some toys. He said, "I have nothing to give you because all the toys are broken." And I was like, "Why?" He's like, "My child breaks all the toys."
Mm.
And so we were like, "Why is that? Is your child really destructive?" But they said, "No, all children are curious. They want to know what's inside. All children are constructive.
Mm.
They break to understand what's inside." So the small toys that we had earlier, we used to have these Hot Wheel cars and these dolls and all these toys. Children would open them up. They open them up to see the gears and the moving parts. And they were able to see, okay, when I move this way, this is what happens. A lot of children had cars where you pull it behind, let it go, and it zooms forward. With more and more technology in toys today, if a child opens a toy, they may only find one circuit board or an IC. So the child will not be able to understand how the IC or the circuit board or all the transistors and the resistors and everything is working with the physical toy. And so the child doesn't learn anything. And that is why I think, for me, my insight is we have to teach this in the schools so that when the child opens up something, he sees a circuit, he sees a MCB, a miniature, a miniature circuit board or a printed circuit board, a PCB. He sees a transistor, he sees a resistor, he sees a capacitor, he sees a power supply, he sees an LED, and he's able to understand,
Right.
how it works and how to manipulate it. What do you think? Right?
That's right. As you just explained, children want to break things to know. Actually, because they are really curious about these things, and that's a sign of being an inventor, right? Because they wanna see the mechanism behind, like technology behind the toy and mechanism behind the toys, because they are in such an age. It's important, uh, important for them to actually not for them, actually for school teach those things, right? Or if they have learned like the things you just mentioned, like LED things and circuit things, then they can see the potential as they break down things. Oh, this part, this component, I know how to use it, and I know how to combine this one with another one, and that's how children can see like their potentials while breaking things. And I believe, I totally agree with you that these this knowledge and the education is really important to be done in school.
Wow. So, how would you do this in school? How can a school principal or trustee listening to our podcast today, if they want to start robotics, how can they do it? How long do you need to teach it? When can we start it? Is it too expensive?
Mm.
What are some of the operational details of it?
Ah, actually, when it comes to our product lines, actually, we have different options for because this one is the most loved tool. More than 2,500 schools across the globe use this product for their STEAM classes. But so you know, each country has different economic status, economic situation, and if some schools need much like affordable option, then we can provide.
Mm.
Uh, so the rather than thinking about the price, the the things to consider is curriculum.
Curriculum.
Curriculum, yeah. As you told me, the right curriculum is really important because mm, this one is an educational tool, and the company that is selling this product must know the best way to teach the subject with these tools, right?
Mm.
So they need to be an expert in this field. And actually, the STEAM educational trends right now in the world is becoming uh like into the digital literacy levels,
Mhm.
as I told you before. Uh, since students have different digital literacy levels, they the schools need to consider what level the students are in right now.
Mm.
And usually educational tools like this provide 4 or 6 levels.
Mhm.
Mhm. Vary from level 1 to level 6 or level 4. As they move on to next level, they they are exposed to more complex logics and more complicated creations, so that they can understand the like real world applications
Uh-huh.
much better. So the curriculum is the thing, and also it is really important. Another thing is how much the edutech company supports the school, because teachers, or actually teachers today, they are not familiar. Some teachers are not familiar with technologies.
Mm.
It's possible, so they need to be trained as well.
Mm.
And so actually, the company that sells this product
Mm.
should be responsible for training sessions for teachers as well. They need to prepare teachers to teach their students in the best way. So those two things are the fourth things to consider.
This is wonderful, right? The
Uh,
curriculum and the
curric-
training.
Training, yeah.
So my question here is, when in Indian schools, when we want to teach physical education,
Mhm.
there is a teacher who is a physical education teacher,
Mhm.
right? There's a physical education teacher who's available, who has the the degree for physical education. When there's a computer teacher, then there is a computer engineer maybe, or a computer science teacher. So a principal who's looking to start a robotics program in their school,
Mhm.
does she need to find a robotics engineer, or are there teachers already in her school who can, with some training, immediately start teaching?
The later one.
Okay.
Yeah, and because it's K-12 level, the all every teacher can teach this STEAM stuff. Once they are actually, if the company trains the teacher, yeah, and they can it doesn't require much time. It doesn't require much time because it's a systematic program to teach teachers. So it takes just 1 or 2 weeks for the teachers to understand what it is and how to proceed with lesson plans. So it doesn't require any robotic engineers. Yeah, yeah,
This is really nice to know, because what's going to happen is that when principals are looking to set up this robotics teaching in their school, they know that they can buy the hardware, they can buy the curriculum, but they still need somebody to teach it. And the fact that the company is able to, take teachers who are currently in the school and then train them and get them to start teaching children, it's going to become a very sustainable thing. I also feel that once kids do level 1 and level 2, maybe a lot of kids may be able to drive the teaching of robotics themselves. And also, it might be a very good collaborative project. And there could also be robotic labs and robotic competitions and things like that. So this is really interesting. So what parents need to know is that robotics is not a distraction.
robotics is not distraction at all. even though even though even though students look like it seems like they are playing with toys, it's not just a play. Along the way, the students can get knowledge of these machines, and these understanding these machines is really important. And robotics starts from breaking things down. Like, yeah, like that's why we made these sensors can be separate. Mhm. All the machines, for example, smartphones, are not just one component. They need, actually, if you break a smartphone down, then there can be hundreds of components in the smartphone. Students, since it's a physical activities, they can build things and break down again, and they build things again. But in the process, they can have, they can learn very critical and crucial things. And those are really basic principles of robotics and to be an inventor in 2023, this digital era.
This is absolutely brilliant. I think the goal of our education and of our schools is to ensure that the children in our schools get the most up to date and the most current and the most technologically advanced teaching and learning, so that they can become inventors, they can become entrepreneurs, they can become problem solvers. And no matter where they are, if they're working in small companies or large companies, they are able to think computationally, they're able to think of solving problems, they're able to have the confidence to break something down and put it back together. And that reminds me of a beautiful joke that I heard sometime. There was a party, and there were two people who came to that party,
Mhm.
and one of the persons who came to that party was a cardiologist, a heart surgeon,
Well,
and another person was a machinist,
mhm.
somebody who works with machines. And so they had to introduce themselves. And the cardiologist was like, "I'm a cardiologist. I work with human heart.
Mhm.
Um, what do you do?" And the machinist is like, I'm a machinist. I work with machines. I work with engines. And so some of the people felt that maybe the cardiologist was more superior than the machinist, the engine person. And for that, the engine person said, "Let me tell you one thing. I can take a machine and completely open it into all its parts.
Mhm.
Every part, I can keep it separate.
Mm.
and then I can put it all back together and the machine will work perfectly. Can the cardiologist do with a human heart? So that was like, like on a lighter note, that was a joke to understand the idea behind destructing and reconstructing again and ensuring that it is useful. I think children need that.
Yes, because that requires actually, if it is not that specific in their in the student's mind, they follow flow charts. They are unconsciously having in their mind because they they need to assemble things in order, right? And the fact they can, or they can make it back to the one before breaking it down, they understand the the assembling steps, which means they know the flow charts, and that's that is really important thing. Because every when you do programming, or other engineering things, understanding each step is really important because each step can affect and can yield into different results. And the fact that students can make it back to the one before breaking one is he's really genius because he knows how to do it. He knows how to make it back, right?
Yeah.
Hmm. And that's the thing. And if your children do like meaning, some students can do things that is that are really meaningless sometimes,
Mm.
due to distraction or like less uh, focus problem things. But for example, if they do just the same thing without trying to understand
Mm.
what it is, then it's meaningless. Yes, that's definitely meaningless. However, if they want to if they are passionate about something, then they are trying to do something that cannot invisible by parents, right? Cannot Parents cannot see. Uh, they try to find out the principle that are behind the toys, behind the robots. So if they are really passionate about breaking it down and making back, I I hope parents don't try to stop them, but just what observe what they're doing. Yeah,
This is so brilliant because what you're saying is children develop process thinking.
right. Ah, yeah, process thinking definitely.
They develop the computational thinking, the sequential thinking, the systematic thinking, right? And that is something that is very, very, very essential and very, very powerful. What I'm also thinking is this process thinking and the systematic thinking will help children even in other aspects of their life, in decision making,
Definitely, that's true.
approach to problems which are non-technological,
Mm-hmm.
and I think these are things that are that make a difference among people. I think uh, people who take good decisions versus people who have made inefficient choices or ineffective choices, perhaps the way they think and approach the problem, their problem solving framework or their problem solving flowchart might give us an insight on why they have better outcomes in their life. Um, Understanding that everything is a component and understanding that components have a structure, have a purpose, and they are able to then take something that is physical and then completely metaphorically use it into something that is not physical, even using with their emotions and things like that. So I think this will help develop the overall perspective of a child, not just their understanding of technology and robotics and programming and coding and thinking, but also allows them to approach life, you know, in many ways. And giving confidence to children
Absolutely.
today makes them happier and sets them up for success, especially during the very difficult teenage years. I think this is something that you touched upon.
Absolutely, absolutely. Cannot deny because the way you think is your habit. Yeah, because you the structure of your thinking has been already made and is a habit. Uh, if students learn how to think, like how to systematic thinking, then that becomes their habit, so that they can approach problems in different ways. And actually, as if someone sees, let's say, a device and that looks complicated, then some students and some people don't want to think about it, don't want to think about the technology behind it, because he knows, or even though he gets explanation on the technology, or he doesn't know, he knows he doesn't understand that. It's, you know what I'm telling you. Yeah,
Yes.
yeah. The confidence is really important, but also the thinking that I can understand this. Or that is really important. It's beyond confi I forgot the word.
Confidence.
Confidence. Yeah, it's beyond confidence.
It's also competence. When he
Yes.
feels that I can do it,
Yeah, it's confidence.
I will crack this problem.
Mm-hmm.
I mean, that's the kind of children we want to make today. We
Yep.
want to make children who are confident,
Mm-hmm.
who are competent,
Right.
who have the skills to do something,
Mm-hmm.
to crack something, to make something, to solve something, to sell something. I think these are things that India needs as a nation, especially with over 1 billion population, like 140 crore. With that kind of population and one of the largest young people in the world being in India, imagine the democratic dividend. That's what they're talking about, this dividend that India has, and how we can empower these children with the right experiences through exposure. You know, that'll probably change their perspectives or set them up for success in their lives.
Yeah, Indian students can change the world, because it's, if they have the habit to approach things systematically, then imagine, how many students here is really big population. And I know Indian students are really good at engineering things, the STEM things. And if they have systematic and critical thinking skills, and they approach real world issues in through that approach, then I believe there will they they can solve many issues the world is experiencing right now, and the world will be a better place. Yeah, through their knowledge.
Thank you. Thank you so much, Hugh Kim, for talking to us. Hugh Kim is from Lux Robo, and he's in our studios today for the Will Talks podcast, and he's been able to give us such beautiful insight about how schools and children today need to think about robotics, and how children can learn system thinking, systematic thinking, and how we can possibly we are best suited. Indian students are best suited to solve so many problems the world has today, to make the world a much better place. Thank you.
Thank you. It was a good time for me to discuss these things. Thank you.